Welcome to this explainer. Okay, today we are tackling something pretty wild about achieving true museum quality color accuracy in your digital archives. If you've spent any time digitizing old photos, negatives, or artworks, you already know the basics of setting up a camera and a copy stand. But today, we're going for a massive upgrade. We need to move beyond just setting a custom white balance and step up to creating a professional color profile. Because the absolute key to true professional color accuracy is completely eliminating all those assumptions your editing software is making about your camera.
So let's dive right into this. Picture it. You've got this priceless vintage family photo sitting perfectly flat on your copy stand. Your lights are angled beautifully, and you've carefully set a custom white balance using your trusty gray card. Boom, you're good to go, right? Well, that brings up a pretty crucial question. Is custom white balance actually enough? The surprising answer here is no. It's a great start for sure, but relying purely on white balance means you might not be capturing the true colors of your historical media. You might actually just be looking at a highly polished illusion. See, there's a fundamental difference between what your standard editing software thinks looks good and what professional archivists actually demand. Most software out there defaults to what we call pleasing color. It loves to boost the saturation, apply these punchy S-curves, and basically just make your images pop. And hey, it looks great on social media. But on the flip side, we have accurate color, and this is a whole different ballgame. This is about strict scientific neutrality. It demands a flat, linear response curve. This is the exact uncompromised standard required by professional institutions, like the Library of Congress, to ensure absolute historical accuracy over aesthetic beauty. Now, you might be wondering, why doesn't standard software just give us accurate colors straight out of the box? Because generic profiles, things like Adobe Standard or Nikon Z7 default, well, they're literally just guesses. Your software is essentially treating your camera like a blind date. It's making a ton of assumptions about how your specific sensor and your specific lens are going to react to light. And let me tell you, that guesswork is rarely a perfect match for archival grade work. If we want museum quality, we have to eliminate the software assumptions entirely. And that brings us to the core concept of our explainer today, device characterization. It sounds a little intimidating, but it's really just the scientific pivot from that software guesswork to absolute tailored precision. By creating a custom input profile, like a .dcp or .icc file, you are handing your editing program a precise mathematical lookup table. You're finally telling the software exactly how your specific camera interprets color under your exact controlled lighting. No more guessing. To really grasp how we measure this accuracy, we kind of need to demystify a bit of industry jargon. You'll hear professionals talk a lot about delta E. The E actually stands for Empfindung, which is the German word for sensation. Basically, it's a standard mathematical metric that quantifies the exact measurable difference between the physical color of the photo sitting right there on your desk and the digital color captured in your file. The lower this number is, the more truthful your digital file is. So, what's the magic number we're aiming for here? Less than 3.0. If you can get your delta E below 3.0, the human eye literally cannot see the difference between your computer monitor and the physical photo when you hold them side by side in 5,000 Kelvin light. That's incredible, right? This proves that professional digitizing isn't just about throwing thousands of dollars at expensive gear, it's entirely about mathematical precision and controlling your environment. This strict mathematical approach is actually governed by something called the FAGI standard. FAGI stands for the Federal Agency's Digital Guidelines Initiative. It's the collaborative framework used by the big players, like the Library of Congress and the National Archives, and it features a 1 to 4-star rating system. Reaching these federal guidelines, especially hitting that sweet spot of a 3-star or 4-star rating, means completely abandoning those standard JPEG S-curves I mentioned earlier. You literally have to embrace flat, linear, raw data so you can perfectly preserve every ounce of data in your shadows and highlights. All right, Section 1, the essential toolkit for custom profiling. Let's see what physical gear we need to actually make this happen. The great news is this process is surprisingly accessible. You absolutely do not need a massive $50,000 museum setup. You can actually build an affordable FAGI light kit at home that delivers the exact same professional math. Look at the difference here. Instead of a $1,000 ISA golden thread target, you can grab a Calibrate or X-Rite color checker passport for around $120. Instead of ultra-expensive enterprise software, you can use Lumivera or even the completely free raw therapy to apply your profiles. And for lighting, as long as you're using LED bulbs with a color rendering index, or CRI, of 95 or higher, you are accurately capturing the full spectrum of your media. It's a total game changer. But okay, here is a critical rule you absolutely cannot break. The color reference target has to be photographed under the exact light used for your archives. Your target is your scientific known truth. If you bump your LED lamps, change their position, or even adjust their power, you've completely changed how that light interacts with your camera. And that means, yep, you have to shoot the target again and generate a brand new profile. Consistency is absolutely vital here, folks. Moving right along to our next section, the 3-step professional workflow. Let's break down the exact steps to build this profile. Honestly, the whole thing boils down to 3 definitive steps: the shoot, the engine, and the application. I know it sounds like a deeply complex scientific endeavor, but when you break it down into this repeatable workflow, it's actually incredibly straightforward for any amateur archivist to pull off. Let's dive into step 1, the shoot. You lay your color checker target perfectly flat on your copy stand, and you make sure your camera sensor is completely parallel to it. We want zero keystoning or distortion here. Center it right under those high CRI 95 plus LEDs. Now, exposure is the make or break moment here. You want to aim for that 18% middle gray patch on the target to sit right around L equals 50, meaning a lightness value of exactly 50 on your software's readout. Oh, and whatever you do, do not clip the white patches. This perfectly exposed shot becomes the absolute foundation for your custom white balance and your entire color profile. Next up, step 2, the engine. This is where the mathematical magic happens inside your profiling software. Whether you're using Calibrite's free software or a really high-end tool like LumaRiver, you just import the raw image of your target. The software takes over, automatically aligning a digital grid perfectly over the colored patches. It then calculates the exact deviation between what your camera sensor captured and the true known scientific values of those physical colors. It crunches the numbers and spits out a highly precise lookup table saved as a .dcp or .icc file. And finally, we hit step 3, application. You just head back into your editing software like Lightroom or Capture One, select all the historical images you digitized under that specific lighting setup, and simply apply your newly created custom profile. This step is crucial because it ensures that your entire tonal range, from the absolute deepest shadows all the way to the brightest highlights, is rendered perfectly neutral. It entirely strips away the software's guesswork and removes any subtle color casts that were introduced by your LEDs or your specific camera sensor. Okay, but how do you actually know if you did it right? That brings us to target validation, which is often called the open dice secret in archival circles. You don't have to just sit there and guess if your math is right. You can download this completely free software called Open Dice directly from the Library of Congress. Just feed it your final profiled scan of your color checker. The software analyzes the whole thing and tells you your exact mean delta E. If that number comes back under 4.0, huge congratulations. You have independently mathematically confirmed that your home setup meets a professional FADG baseline. Let's pull back for a second and connect all this technical process back to our ultimate why. Why go through all this extra effort? Because you aren't just taking photos, you are creating an archival master. By minimizing that color error, you are locking in the absolute closest possible representation of the original physical media. This is what truly secures your family legacy or your historical archive. You're future-proofing it, making sure that any future digital restorations are working from an uncompromised, mathematically truthful digital duplicate. I want to leave you with this really powerful guiding principle. FADG isn't about how much you spend, it's about how much you control. I think this is incredibly empowering. It proves that discipline, a linear workflow, and a standard color target will absolutely always beat some wildly expensive piece of automated gear that's just running on default settings. You literally hold the power to create museum-grade archives right there on your desk. So, as we wrap up, I want to leave you with one final, slightly provocative question. Are your digital archives actually telling the truth, or are they just telling you what your software wants you to see? It's time to take total control of your colors, move beyond generic white balance, eliminate those default assumptions once and for all, and start building professional profiles that truly honor the history you're trying to preserve. Thanks so much for joining me on this explainer.